Hello friends, welcome to Ekeeda. Title of the lecture is Sequence Impedances and Sequence Network of Synchronous Machine. So sequence impedance of synchronous machine. In this case, synchronous machine is designed with symmetrical bindings. And it induces EMF. It induces EMFs of the positive sequence only. So positive sequence generator impedance is a value. Positive sequence generator impedance is the value found when positive sequence current flows due to an imposed positive sequence set of voltages. Positive sequence set of voltages. Neglecting the armature resistance, as armature resistance is very small and positive sequence impedance of the machine is positive sequence impedance of the machine is Z1, this is equals to JXD double dash if subtransient is of interest. This is equation number 1. Z1, this is equals to JXD dash if transient is of interest. Equation number 2. And x1, this is equals to JXD if steady state value is of interest. This is equation number 3. So positive sequence generator impedance is the value found with positive sequence current flows due to the imposed positive sequence set of voltages, and positive sequence impedances of the machine is given for subtransient, transient and steady state value. Now with the flow of negative sequence current in the flow of negative sequence current in the stator, the net flux in the air gap rotates at opposite direction to the stator. Because of the negative sequence of the current, the net flux in the air gap rotates the opposite direction to that of the stator. Therefore, the net flux rotates twice the synchronous speed of the rotor. So in this case, field winding has no influence. In this case, field winding has no influence because field voltage is associated with positive sequence variable and only damper winding produces an effect in quadrature axis. So because of the negative sequence of current, net flux in the air gap rotates at the opposite direction to the rotor, and the net flux rotates twice the synchronous speed of the rotor. So in this case, field winding has no influence because field voltage is associated with the positive sequence variable, and only damper winding produces an effect in the quadrature axis. Therefore, the negative sequence impedance, therefore negative sequence impedance is close to positive sequence subtransient impedance. So Z2, negative sequence impedance Z2 is close to the positive sequence subtransient impedance. So positive sequence subtransient is JXT double dash. This is equation number 4. This means field winding also has no influence, and because of the field voltage which is associated with the positive sequence, and only damper winding produces an effect in the quadrature axis. Now in a synchronous machine, no zero sequence voltage is induced. So zero sequence impedance of the machine is due to the flow of zero sequence current, and the flow of zero sequence current create three mmfs which are in time phase but are distributed in space phase by 120 degree, means resultant is zero, therefore resultant air gap flux to be zero, and there is no reactance due to the armature reaction. Zero sequence impedance of the machine Zero sequence impedance of the machine is due to the flow of zero sequence current, and zero sequence current creates 3 mmfs which are in time phase but are distributed in space phase by 120 degree, means resultant is 0. Therefore, resultant air gap flux would be 0, and there is no reactance due to armature reaction. Hence, machine offers a very small reactance due to the leakage flux. Therefore, rotor winding present leakage reactance only to the flow of zero sequence current. That means Z0, this is equals to JXL. This is equation number 5. Because the rotor winding present leakage reactance only to the flow of zero sequence current. So these are the four equations for positive, negative, and zero sequence. Now, sequence network of a loaded synchronous machine. So, this figure this is EA, EB, and EC. This is neutral. This is ZN, current, IA, current, IB, and current IC So this is VA, this is neutral N. So this is VA, then this is VB, and this is VC. Load is connected. So this ZS, this is synchronous ZS. All the reactances given for the machine. And this is your neutral. Neutral is grounded through an impedance Zn that is taken, and this is force voltage VA, VB and VC, and current IA, IB and IC. Phase voltage VA, VB, VC and current IA, IB and IC. So phase voltage is VA, VB, VC and current IA, IB and IC. And these are your magnitudes EA, EB and EC. This EA, EB, EC are balanced actually because they are separated by 180 degree. Therefore, balanced three phase of a synchronous machine, balanced three phase of synchronous machine is represented as a positive sequence set of phasors. Means this EA, this is equals to EA as reference. So EB, this is equals to beta EA, and EC, this is equals to beta square EA. Or in matrix form we can write this as EA, EB, EC, this is equals to 1 beta beta square into EA. Suppose this is equation number 6. So from figure we can write, apply KVL in this figure. So from this equation you can write EA is equals to BA is equals to EA minus ZS into IA minus Zn into In. See this figure. So when you apply KVL, IA into ZS, when you apply KVL in this, so IA into ZS plus BA, IA ZS plus BA plus Zn into In minus EA, this is equals to 0. Or you can write this equation as BA, this is equals, this equation you can write VA, this is equals to EA minus ZS into IA minus Zn into In. Similarly for VB, for phase B and C, VB this is equals to EB minus ZS into IB minus Zn into In. Similarly for C, so VC this is equals to EC minus ZS into IC minus Zn into In. This is equation number 7. Now another thing is current In is entering. This is the direction of current In. In is entering in this direction and this IA is leaving this terminal. So IA is equals to In, this is equals to IA plus IB plus IC. This is equation number 8. So using equation 7 and 8, using equation 7 and 8, we can write BA, BB, BC, this is equals to EA, EB, EC minus ZS plus Zn into Zn 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 Zs plus Zn 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 Zs plus Zn Ia Ib Ic. This is equation number 9. On putting the value of in, we got this equation. So, or in compact form, we can write this as Vp. This is equals to Ep minus Zp into Ip, where Vp is equals to Va Vp Vc, or Va Vb Vc transpose. Ep is equals to Ea Eb Ec transpose. Ip is equals to Ia Ib Ic transpose, and Zp, this is equals to Zs plus Zn 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 Zs plus Zn 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 Zs plus Zn. Now we know Vp, this is equals to AVS, this we know. So this is equation number, this is 10, this is equation number 11, or we can write this as EP, this is equals to AES, this is equation number 12. Similarly, for current, IP, this is equals to AIS, this is equation number 13, where VS, this is equals to BA1, BA2, BA0 transpose. ES, this is equals to EA1, EA2, EA0 transpose. C, we already defined these terms. IS, this is equals to IA1, IA2, IA0 transpose, and A is equals to 1, 1, 1, beta square, beta, 1, beta, beta square, 1. We already defined these terms. Now substituting equation of Vp, Ep and Ip from equation 11, 12 and 13 into equation 10. We'll get Vp, this is equals to AVS. Vp is equals to Ep minus Zp Ip. Equation 10 is Vp, this is equals to Ep minus Zp Ip. So put the value, Vp is equals to AVS. This is equals to AES minus Zp, and Ip is equals to AIS. This is equation number 14. So multiply equation 14 by A inverse. On multiplying equation 14 by A inverse, we get Vs, this is equals to Es minus A inverse Zp AIS. This is equation number 15. Then Vs, this is equals to Es minus Zs dash into Is. This is equation number 16, where Zs dash, this is equals to A inverse Zp into A, and A inverse Zp into A, this is equals to we know 1 by 3, 1 beta, beta square, 1 beta square beta, 1 1. We already know the value. A inverse 1 by 3, 1 beta beta square, 1 beta square beta, 1 1 1. Zt is equals to Zs plus Zn, Zn Zn, Zs plus Zn, 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 Zs plus Zn, 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 Zs plus Zn into A, and we know A, this is equals to 1 1 1 beta square beta 1 beta beta square 1. So if you multiply all this, you'll get Zs dash, this is equals to, on multiplying all this, we'll get Zs 0 0 0 Zs 0 0 0 Zs plus 3 Zn. This is equation number 17. So on multiplying all these terms, we'll get Zs dash, this is equals to Zs 0 0 0 Zs 0 0 0 Zs plus 3 Zn. Now this Vs, this is equals to Es minus Zs dash Is. So put this in equation number 16. Vs, this is equals to Es minus Zs dash Is. So put the value of Zs dash. So Vs is Va1, Va2, Va0. Es, this is equals to Ea1, Ea2, Ea0 minus Zs dash, this is equals to Zs 0 0 0 Zs 0 0 0 Zs plus 3 Zn, and Is, this is equals to Ia1, Ia2, Ia0. This is equation number 18. Now note that Ea1, this is equals to Ea, and Ea2, this is equals to Ea0, this is equals to 0, because synchronous machine, in that positive sequence voltage is induced. Therefore Ea2, this is equals to Ea0, and this is equals to 0. Therefore Va1, Va2, Va0, this is equals to Ea0 0 minus Zs 0 0 0 Zs 0 0 0 Zs plus 3 Zn into Ia1, Ia2, Ia0. This is equation number 19. That means from equation 19, Va1, this is equals to Ea minus Z1 into Ia1. Va2, this is equals to 0 minus Z2 Ia2, and Va0, this is equals to 0 minus Z0 into Ia0. This is equation number 20, 21 and 22, where Z1 is equals to Zs, Z2 is equals to Zs, and Z0 is equals to Zs plus 3 Zn. So this is a positive sequence impedance. This is negative sequence impedance, and this is zero sequence. Now positive negative zero sequence network of synchronous machine. Positive negative and zero sequence network of synchronous machine is shown in figure below. So they are independent to each other. So this is a reference EA plus minus Z1. This is IA1 and this is VA1. This is for positive sequence. Figure A for positive sequence network. Now second figure for negative sequence. So EA is 0 in the negative sequence. So this is C for negative, it is minus Z2 IA2. So Z2 IA2. This is VA2. This is reference for negative sequence network. This figure is for negative sequence network. Now for zero sequence, VA0, Z0, IA0. This is reference. This is figure C for zero sequence network. So from above derivation, some observations you can make. That first observation is three sequence network are independent, means no connectivity. Three sequence network are independent. Second observation, neutral of the system is a reference for positive and negative sequence network. Second observation is the neutral of the system is the reference for positive and negative sequence network, whereas for zero, ground is the reference. Next observation, there is no voltage source in the C. There is no voltage source in the negative and zero sequence network. Only positive sequence has the voltage source. There is no voltage source in the negative or zero sequence network. Only positive sequence network has a voltage source. And the last observation, the grounding impedance is reflected in the zero. Grounding impedance is reflected in the zero sequence network as 3Zn. See, it is Zs plus 3Zr. So grounding impedance is reflected in the zero sequence network as 3Zn. These are some observations which we derive from above derivation. Thank you.